Hello YouTube, fellow math students and math teachers. This is Devor again, and we are going to be examining units. This is from the Mathematics Vision Project Math 1 curriculum, Module 1. And before you even think about getting started with this activity, you should make sure that you have completed serving up symbols, which is the task before this one. In particular, it would be an incredibly good idea to have finished the table, that long table there at the front of the activity. And it's not just for this task. You're going to be reusing those same symbols from serving up symbols in future tasks throughout this module. So if you have not completed serving up symbols, do it now. Come back to this video when you're a little more ready. Today we're going to be examining the effect of doing arithmetic while staying true to our units. We're going to be examining addition and subtraction, multiplication, and finishing up with division. This is to make sure that when we are doing arithmetic with numbers that have units attached, and then say, if I were to ask you what units your answer is in, you need to be able to explain that to me or to someone who asks. This is part of the whole needing the answer to make sense idea. So we're going to look at in what circumstances we can do arithmetic and still have our units make sense, and in what circumstances we cannot. We're going to come up with several rules. This is going to be a bit of a longer video than the ones I've done before, but it's because it's a longer task. First thing we're looking at here, we've got units in addition and subtraction. The question is, we are adding NE plus NS plus NB. These are all off of your serving up symbols table. We have B plus G, and then we have M plus W. Let's examine each of these individually, and I think that by the end you'll see exactly what's going on here. We are measuring NE, NS, and NB. Now, if you are following along with your symbols table, you should be able to pull these straight off. We have a number of entrees, plus a number of sides, plus a number of beverages. Which, when we add all those up, we're really counting food items. Now, they're not all exactly the same. I mean, an entree is not the same thing as a side dish, which is not the same thing as a beverage. But when we add them all up, we can think about it as, well, we're just counting food. We're not really particular about the kind of food, but we're just counting food items. And we can make that work. That's something that makes sense to us. Next one we have boys, number of boys, plus the number of girls, which means that we are really adding students. And again, we're not dealing with the exact same kind of people, but in the end, we can wrap our brains around the fact that we are indeed counting students. Finally, we have M, which stands for minutes. It's the minutes that have elapsed since the beginning of the period, plus the number of food servers in a line. We cannot make the jump as easily here because when we think about adding things together, we've got time and we've got people, and that really doesn't make any sense. Adding an amount of minutes to a number of people, adding those two things together really doesn't make sense. So we can write that here. It doesn't make sense. Frown your face. So let's go back a question here now that we have a little more information. Why were we able to add the first two, but we were not able to add the last one? The answer lies in the fact that the first two have very similar units, while the third one does not. Let's see if we can make a rule about this. In the first two, we have just everything is, in the first one we have everything's a kind of food. Second one, both things we're adding are people. So all units in the sum or difference. So all the units that you're adding or subtracting together need to be in a similar category. And what I mean by a category is, they don't have to be exactly the same, but you have to be able to reason through and say, oh yeah, they're similar. Like people, food items. There are other things similar to that. But just so long as everything is in a similar category, you're going to end out all right. Let's move on to multiplication. We've got NE, CE, LW, GC. So these, again, we are pulling straight off of our table. When we are multiplying or dividing these units, we want to make sure that we are using the rate unit, which is the one that has something per something. If you don't have those rate units, you might want to go back, again, pause this video and make sure that you write them all in using the examples given. So if we're looking at number of entrees, we've got entree per lunch times cost per entree. Remembering back to when you started multiplying fractions, whenever that was, one of the tricks you've probably seen is something called cross-canceling, where you look at the diagonals and you see if there's something in common. If there's something in common, you go ahead and you just cancel it out. In this case, we can do cross-canceling with entrees because the diagonals are the same. When we do our cross-canceling, we are left with cost over lunch, which is not a unit that we've had before, but it's something that we might want to know anyway. And that's the cool thing about doing multiplication and division, really, with some of these units, is this is an opportunity for us to create new units using our existing units. We don't have to create a brand new variable every time we need a new unit. We can sometimes create our own. Let's practice that again down here with L and W. L stands for lines in the cafeteria, if I could spell today, times servers per line. And again, you should see something right away that we can cross-cancel. We can cross-cancel the line. We are left with a server divided by cafeteria, which again is not something that we have on our list. But I think it's a good idea for us to know how many servers there are in the cafeteria, yeah? Finally, we are looking here at G and C. We have girls who buy lunch per day times number of classes per lunch period. We don't see anything that we can cross-cancel here. And if we can't cross-cancel anything, then your answer won't make any sense. All right. So we're once again going to look at the question: why was I able to multiply the first two together but not the second two? The trick is that we were able to make new units with the first two, but not with the third. Don't know why I can't type today. Here's a rule that we can stick with. The ones that we were able to multiply together, we were able to do some cross-canceling. Either the top of one and the bottom of the other, well, actually this will work either way. The top unit of one needs to be the same as the bottom of another, so we can cross-cancel. That's really the trick. You need to be able to cross-cancel, otherwise you're going to run into many, many problems. Let's move on to a special case of multiplication here. We have L representing the length of the cafeteria in feet, W representing the width. So nothing that's from our table, but it's something that we can definitely imagine here. If I were to add up L plus W plus L plus W, think about maybe withdrawing a little box, what that actually means. L plus W plus L plus W. Really what I'm doing is I'm counting the lengths around the whole cafeteria, which really that is a fancy way of saying the perimeter of the cafeteria. Whereas L times W, if you remember your geometry, represents the area of the cafeteria. The thing that we want to keep in mind here is why are we able to add these lengths together as well as multiply them together? And that comes from the way that distance works. When we add lengths, we are measuring in standard units, such as meters, feet, inches, etc. When we multiply lengths, we are measuring in square units. So square meters, square feet, etc. Both standard length units and square units are totally viable ways that we can measure things. They are units that we can work with. And that's something that's special about dealing with lengths in particular. They have this property that when we multiply them together, we're making a new unit, but it's not a new unit. It's the difference between measuring length and area, where we have just regular units like meters and feet, and then when we're measuring area, we always measure in square units like square meters or square feet. What it comes down to is distance is special because we can measure in standard units and square units. However, there is a big however here. Our units need to be the same. For example, we cannot multiply feet and inches together. We're not going to get square feet or square inches if we do that. We have to actually convert and make sure that either both in feet or both are in inches. That's just something that comes from the way that we do this. All right, almost done here, reaching the home stretch. Now we're looking at division. Here we have students and people. Students and, what is it? Number of lunch periods. We can think about this as just students per period. That is a completely viable way of doing it. We can go down the line here. We've got servers per line. Again, these all make perfect sense here. We have students per server, which we can think of as some weird, well, how do I want to say this, like a faculty-student ratio. And then finally, we have SM, which is we have students, but it's different than the students that we have when we just have S, and this is something that we need to account for. We have students per minute, and this is being divided by minutes per period. Now, the reason why I did that is because the SM is not just students. It's a special kind of students. If I wanted just students, I would have used capital S. But this one's a special kind of students. This is students per minute. And remember, this is going back to our fraction stuff. If you are dividing by fractions, remember we don't want to divide by fractions because that's evil and nasty. We want to instead multiply by fractions. Here's how we show that. We keep the first fraction the same, change the division to multiplication, and flip the second fraction. Now this is just a standard multiplication problem like the ones we had above, but you notice that we can't cross-cancel, which is awkward. We once again put our little question mark there because it doesn't make any sense. With division problems, our general rule is we use the quantity when possible. But we need to be careful in case our units need to be more specific, which is what happened in the last one. Alright. Here we have F divided by W, which gives me servers? Yeah. Gives me let's see, we've got servers per cafeteria divided by servers per line. Now the reason why I did this is because if you actually look at your units, they're both counting servers, which is not terribly helpful, which means that we have to default to the rate. Okay, we're going to do the same things we did above, where we keep, change, flip, and oh look, we can cross-cancel. Let's go ahead and do that. Line over cafeteria. Cool. See if we can do a similar kind of thing with this one. We've got price per lunch divided by items per lunch, which again we keep, change, flip, and oh look, that's awful convenient. We cross cancel, we get price per food item. That's if I can spell today. Price over. That's better. Our new rule here is that if we want to be able to divide units, either both tops of our rates need to be the same, or both bottoms need to be the same. That's really it. We're just using our fractions, we're using our awesome fraction skills, and we're just getting it done. Just be careful whenever you're dividing, because sometimes you can use how we did it before, where we were able to do quantity over quantity. But sometimes, if you need to be a little more specific, you're going to need to use the full fraction dividing idea. I hope that this video was helpful to those of you who are working on examining units currently. If you have any questions, comments, or concerns, please feel free to send me an email, come visit me during my office hours, or shoot me a message on my channel, and I would be happy to give you a hand. Once again, this is Devor, and I hope to see you guys in the next video. If you like what you see, please give me a like and a subscribe. Maybe leave a comment if you have any questions. I hope that you guys have a great day, and remember, be awesome!